So today we need to start again this optical fiber chapter. But before moving to that, okay, I need to discuss one more thing, like what is the requirement of optical fiber again. Okay, so maybe in the last time we have skipped this part or we have missed it, but anyway we are coming to the same. So always first we need to look like what happens if optical fiber is not there. Okay, so in the previous time cannot we is there any mean by which we are sending the signal from one place to the another place, or no such things will be available before optical fiber, right? So you need to think of in that direction, that what about before optical fiber, what is the medium by which we are transmitting the signal from one side to the another side. So that is why if you look at, okay, so for that, for comparison purpose or for finding the answer behind this type of thing, you need to look at to the optical, not optical, but you need to look at to the entire electromagnetic spectrum. Okay, so maybe in the first tutorial we have discussed several times of this electromagnetic spectrum part. So if you just draw the wavelength scale as well as the frequency scale, okay, and you note down several numbers, because we have done this activity already. So on one side wavelength will be there, on the another side frequency scale will be there. Okay, and if you look it out carefully, okay, then if you consider the range of, let's say, some megahertz range, okay, 30 megahertz or maybe 1 megahertz onwards, 1 megahertz to up to, let's say, 30 megahertz frequency range, if you consider, then that particular range is for, let's say, you already know which range it is going to be belonging to, right? So that is your radio waves mostly. Okay, so up to 30 or 300 megahertz, up to you can go there. And if you look at that frequency range, so that frequency range signal we are able to send via coaxial cable. So now you people, I hope you people are familiar with the coaxial cable, okay, where the central wire will be of metal, most probably copper, and on the top of that one insulating layer will be there. So that's how you can identify the coaxial cable. And remember that coaxial cable, that wire, central wire will be of with slightly thickness. Okay, the thickness may be there in that case, so that we are knowing as a coaxial cable part. So that coaxial cables can carry the signal up to, let's say, maximum up to 1 gigahertz. Okay, starting from the megahertz range, but that can transmit the data if the frequency or if the signal frequency is in the range of up to 1 gigahertz. So that can be possible to send the signal with coaxial cable. But of course there are certain limits for that medium also, because otherwise no one is thinking for this optical fiber. So why we are thinking about the new devices, because we have some limited in our existing devices. Okay, that's why we are looking forward for the new devices which are working in larger capacity. So that coaxial cable part was working in the range of 1 gigahertz, up to 1 gigahertz. Okay, apart from that there are so many losses also. Okay, you people may find out maybe later on when you search it. So how much losses will be there in the coaxial cable, signal loss will be there, etc. And one of the fine example I will provide it to you, because many of you, I don't know you are from that generation or not, or you are slightly above then. So if you look at in the 90s around, okay, so you may have seen that cable operator thing. Okay, so your TV etc are running based on the cables which are providing by the cable operator. And many a times few people are doing some misbehave with this optical, this their coaxial cable part. Okay, so what they do is they just cut little bit part of that coaxial cable, okay, and then try to tape with another cable. And basically with one connectivity, with one connection, they are running 2 or 3 different TV setups. So what they were doing is they were stealing the data which are flowing through these coaxial cables. Okay, so that's how your data which is going to be propagate through the medium, that is coaxial cable, it is not secure. Anyone can copy, or anyone can uh, trap that data. Okay, so that is why it is not secure basically. In short, if I say, it is not secure because anyone can just put the cut on the cable, coaxial cable, tape it with another wire, and that's it. They are stealing the data. Of course there are again some drawbacks in that also, because you may not get the same clarity of the content with the original one, because you are taping the signal. Okay, but that is the case, people are doing that. So instead of paying for one, I mean they are paying for one, but at least they are enjoying for 2 or 3 more connections. So that's what that flaws will be there in that case, coaxial cable. So apart from the limit for the frequency signal, it also has the drawback of this security part. Okay, so that's why people have started thinking, what about if the range is larger than 1 gigahertz? Okay, and how to secure my data, because now everything comes to this point of the security, how much secure my data is, right? So that's why. So then people thought of like what is the alternate of this coaxial cable, and another reason is that our requirement is getting larger day by day. Okay, so before some time I was happy with this 1 gigahertz signal, but then I realized no, 1 gigahertz signal may not be enough for my purpose. Then I need to increase the frequency range. So suppose if I, what about if I go beyond 1 gigahertz, then this coaxial cable will not be working properly. Okay, because it has limit up to only 1 gigahertz, but beyond that this device, this coaxial cable part will not work properly. So they come out with another idea. Okay, so they come out with waveguide. There is also one device, okay, waveguide. So those people who are from the EC background, okay, or electrical or IC, so they must be reading about this waveguide part in more detail. Okay, so this is also a medium by which you can transmit the signal from one side to the another side, and the waveguide range is starting from more than 1 gigahertz. Okay, so suppose if signal is more than 1 gigahertz, then you people may go for this waveguides, and this has up to again certain range, maybe up to 300 gigahertz. Okay, so this device, this waveguides can work properly. But again, as I said, our requirements are getting day by day. I mean, they are increasing day by day. Okay, so again, people thought of like what happens if I increase the frequency range again more than 300 gigahertz. Okay, उससे भी ज़्यादा frequency का signal if I consider, then this waveguide again is not useful. Okay, so then they come up with this idea of this optical fibers. Okay, so somehow you say waveguide can extend it, though it is claiming that 300 gigahertz, but somehow they can extend it up to 1 terahertz or approximate to that range, because there is not cut to cut value. It almost depends. But if you look at the optical fiber part, so this optical fiber deals precisely in the range of 10 raised to 14 hertz frequency. Okay, so that 10 raised to 14 hertz frequency is nothing but if I write in terms of terahertz. Okay, uh, if you write in terms of terahertz, then it is like some few terahertz to few hundred terahertz frequency. Okay, 10 raised to 14 hertz, you can write maybe around few terahertz to few hundred terahertz, you can write it that in that part. So in that range your optical fibers are properly working. And why we are using light signal, that is also important. Why we are using light source? Because the terahertz, I'm audible?
Yes, sir.
Yes, sir.
Yes, sir, you're
Someone
audible.
saying in the
Yes,
chat
sir.
box. Someone saying in the chat box. Anyway, so what I'm saying is the important part is this: why we are using the light only in the optical fiber cables. Because if you see the frequency range, okay, that is around terahertz range. Okay, terahertz or maybe few hundred terahertz, and the same frequency matching with this laser light source or light, any light source you compare. Okay, so if you look at the light source frequency or light frequency basically, so wavelength we are knowing 400 to 700 nanometer, but if you convert into the frequency, that comes into the same range, and that is why we are using the lights, so that it can transmit the data over there. Okay, light signal we are propagating. So that's why we are saying optical fibers are carrying the light signal, because of this reason only, because that can support this terahertz frequency through it. Okay, another point someone has asked, like waveguide is a cable. No, it is not a cable. Okay, it's a different structure. Fine, so that part I will leave it to you people. I give you the hint that it is not a cable. Okay, so waveguides are having some different structure. Sometimes people are saying is a rectangle waveguide, rectangular. Okay, there are circular waveguide also, so variety of categories will be there. Okay, so if you are interested in more about this waveguide, because that is very important part, especially for the EC, electrical and IC people. Okay, so if you are from that branch, then of course you can go to that, okay, for more details. But still don't need to worry, in the higher semester you are going to cover that part. Okay, so choice is up to you, but you, if you want, you take some idea from the internet also. And then coming to this range, as I discussed, so optical fibers we are using, and last time already we have discussed this single mode optical fiber. Okay, and advantage, disadvantages, everything we have seen carefully, properly. Now coming to the second part, that's a multi-mode. Okay, so this one, you slide on this, you are on this slide, multi-mode optical fiber. So again, everything is very clear from the name itself. Multi-mode means more than one mode. Okay, and if I remember, I have told you that what is the meaning of mode also. So mode is basically the path, number of path. Okay, possible path basically. Actually there are infinite number of paths, theoretically if you speak, but you have to look at the practical or the possible number of path which can be possible, which can be in the optical fiber cable. So the number of possible paths we are knowing as a mode. Okay, so multi-mode means, of course, more than one mode, that means more than one path, if it is allowed in the optical fiber, then that optical fiber we are saying is a multi-mode optical fiber. Okay, and I have discussed this also, that this type of multi-mode optical fiber system can be useful for a local distance. Okay, short distance or within a building or within a campus like this. So you can always go for this multi-mode because it is cheap compared to the single mode optical fiber, first preference. Because whenever you talk about on the large scale, you also need to look at about the cost factor. Okay, and at the same time you need to compare the output also. So if in a within a small interval or a small campus or a small building, if your criteria is fulfilling, then you can go for the multi mode. So then no need to spend a lot of amount on the single mode optical fiber. So that's why people are preferring it for a local distances. And even you see the light sources also, you don't require laser light compulsorily, but in the single mode laser is must. But here you see laser or led, whichever light source I want, I can go for that. Okay, and this is the pictorial way you see on the screen. Okay, and purposefully you see I have kept this core part is larger compared to the previous case, so that one can easily differentiate what is the single mode and multi mode. Single mode means the core is very narrow, only one mode can be possible in, but in multi mode the core part is slightly large compared to the single mode optical fiber. Okay, and on the top of that, of course, cladding will be there, and then outer layer also there. But in general, when you draw the diagram in the exam in your notebook, generally people prefers to identify core and cladding part. Okay, they are not putting this this outer layer or jacket something. So this is how you check it out, and these are the paths you can see which I have
Yes.
represented with arrows. Yes.
Sir, are the three
Yeah.
frequencies different from each other or they should be same?
No, frequencies are different. See, this suppose if you talk about LEDs, right? LED is, it is not a monochromatic source. Okay, it may have the variation in the frequencies. Okay,
But
so accordingly it will emit. Huh?
then different frequency will, coincide and they will lose their data, no?
Yes, exactly. That's what I told, that for a long distance, you cannot rely on this multimode optical fiber cable because they are going to disperse. They are going to interfere with each other. Okay. So we'll come to that. I will coming to that point only, but I have given you the idea. That is why I said that this kind of system, multimode optical fiber, cannot be useful for the longer distance communication. Okay.
सर
That is
मल्टीमीटर
why.
का सर फायदा क्या है सर? मतलब है ना, बस सिग्नल ही तो सर डिफरेंट पाथ ट्रेवल कर रहे हैं, इससे बढ़िया सिंगल मोड को ही ले लो।
हाँ ले लो, लेकिन सिंगल मोड का कॉस्टिंग ज्यादा है. Right, when see, whenever I mean, there are many times when you need to compare cost factor also. Okay, so but for a local distance, and again you see, at the same time you need to allow so much bandwidth. Okay, so then in the multi-mode, so much network cables you need to put it down for a single task, but in multi-mode easily one can, you see, this core diameter is large. Okay, so all such activity in a local place can be accommodated. So that is the main difference. Of course you can go for single mode
टास्क तो
if you are,
क्लियर
if you are. Huh?
टास्क जो आउटपुट हमें चाहिए वो तो हमें क्लियर मिलेगा ही नहीं क्योंकि ये इंटरफेरेंस की वजह से।
हाँ, लेकिन कई बार क्या होता है, सी मेनी टाइम्स व्हाट वी आर हैप्पी विद, सी कई बार आप कुछ मार्केट में, लेट्स टेक मी एन एग्जांपल, आप मार्केट में कुछ परचेस करने जाते हो, राइट, कोई चीज अच्छी है, लेकिन कहीं ना कहीं आप उसको कंप्रोमाइज करते हो ना चीज को, कि चलो ये फीचर मुझे अगर कम प्राइस में मिल जा रहा है तो मैं एक या दो चीजें एमिट कर दूंगा, कि चलो यार नहीं मिल रहा है तो दैट्स फाइन. जैसे हम लोग, लेट्स टेक एन एग्जांपल फॉर मोबाइल फोन, है ना, कई बार हम लोग उसका प्रोसेसर देखते हैं कि यार अच्छा ठीक है, ऑक्टा कोर है, भले उसमें कैमरा अच्छा नहीं है, तो विल डील इट कि वही है, मुझे कैमरे का इतना रिक्वायरमेंट नहीं है, सपोज फॉर एग्जांपल, मुझे तो प्रोसेसर से मतलब है और वो मुझे कम प्राइस में मिल जा रहा है, देन आई विल बी हैप्पी फॉर दैट. सो दैट इज दैट काइंड ऑफ सिचुएशन यू कैन कंपेयर, कि भाई आपका रिक्वायरमेंट क्या है, मेरा पर्पस है कि ये मेरा काम फुलफिल हो जाना चाहिए, आई विल बी हैप्पी विद दैट, इवन दो सम लॉसेस विल बी देयर. सो वन कैन ऑलवेज गो फॉर दैट. ओके, तो ये सारी चीज आती है कॉस्ट कटिंग, बिकॉज राइट नाउ यू मे बी थिंकिंग ऑफ वन piece of optical fiber, but you see there is a large number we required. So this cost factor, and I will come to that also, it is not only the optical fiber, there are several components you will require for let's say connecting. Okay, for transmitting also you required something. So there are several things are related with a system. It is not a only single optical fiber that you purchase it and that's it, your work is over and you can transmit the data very easily. No, there are several components. We'll discuss that also, what are the other components we required. So if you look at overall picture, you required lot of money. Okay, then only you will run this setup. Right now of course it is not that much costly, but still if you go on the large scale, this will affect your cost parameter. Okay, but for a
Sir,
limited distance, yes.
फाइबर कितने लाइक फ्रीक्वेंसी एक्सेप्ट कर सकता है मैक्सिमम?
मैंने बोला तो टेराहर्ट्ज की रेंज में सिग्नल को कर सकता है।
नहीं, मतलब हमने जैसे एक फ्रीक्वेंसी दी, दो फ्रीक्वेंसी दी, अलग डिफरेंट फ्रीक्वेंसीज की बात कर रही हूँ।
हाँ, वो आपको देखना पड़ेगा कि वो जो आप सिग्नल प्रोपोगेट करवा रहे हो इनसाइड उसके ऑप्टिकल फाइबर के अंदर, वो टीआईआर पैटर्न को फॉलो कर रहा है कि नहीं कर रहा है। ठीक है, सेकंड चीज आपको देखना है कि वो सिंगल मोड है मल्टी मोड है। अगर सिंगल मोड होगा तो एक ही पॉसिबल पाथ उसमें फॉलो करेगा, इसलिए हम लोग लेजर लाइट को यूज करते हैं, क्योंकि उसका जो आउटपुट है वो मोनोक्रोमेटिक होता है। ठीक है, यानी कि उसकी फ्रीक्वेंसी में बहुत कम वेरिएशन होगा, तो इसीलिए उसमें आउटपुट भी ज्यादा आता है, क्योंकि डिस्टर्बेंस होने की चांस ही नहीं है। ओनली वन वन फ्रीक्वेंसी इज ट्रेवलिंग, राइट, देन देयर विल बी नो चांस ऑफ डिस्पर्सिंग, कोई इंटरफेयर करने वाला है ही नहीं उसमें। बट इफ यू यूज एलईडी तो डिस्पर्स होने के भी चांस है, इंटरफेयर करने के भी चांस है, एंड दैट इज वाई जो आउटपुट आपको मिलेगा वो कम मिलेगा। क्लियर, वी हैव दैट डायग्राम आल्सो, ओके, फॉर मोर क्लैरिटी। सो लेट मी कमिंग टू द नेक्स्ट स्लाइड, again we'll discuss the same thing which you have right now. Okay, can we calculate the length till which multimode will work? Yes, of course you can calculate it out. It all depends on the signal basically you receive at the other end. Okay, so you need to look it out that at the beginning this much my input intensity of my input, and what is the output I am getting at the other end. So if you see that that majority of the signal you are attenuated or getting lost, that means that particular distance is not enough, so आपको distance कम करना पड़ेगा. So depending on the requirement, suppose at the input, let's say the input is 100%, but how much output you required, 70%, 80%. So accordingly you can define the length, that okay, up to this much length I am getting this much output. So one can define or one can find out the length also. Okay, as I said in the earlier lecture, if you remember, there are losses. Okay, so the current losses are 0.2 dB per kilometer. So with the help of that you can easily identify that up to how much long distance I can carry out with this optical fiber setup. Okay, and again remember, this is not a fixed number for every fiber. It all depends on several properties, what kind of glass material you are going to use. Okay, what is the refractive index of core and cladding. So there are several parameters related to with that, but I have given you one simple idea that around 0.2 dB or 0.3 dB per kilometer is the loss we are facing. Okay, but of course there may be some fiber in which these losses are even less than this amount also. So that all depends on the glass properties or the material properties by which you are making the optical fibers. Is it okay now? So let me come to the another one. Okay, so here you see again, for comparison purpose, so that you people can have clear idea, you see this multimode optical fiber, and you see this core part. Core is larger compared to this. Okay, you see this, and here you see this on this single mode, very narrow core, but here in the multi-mode core size is large compared to the single mode. And you see there are different modes, that means different path basically, right? So different paths are going to be followed inside this, because the core diameter is large, but here only one mode is possible because of this narrow core diameter. And of course this is the horizontal part, the cross sectional part you see. Okay, so this is the core part completely with this. Okay, up to here, on the top of this is the cladding. Okay, you see, and here is the core for this single mode. So I hope this pictorial way is very clear to you. Okay, now come to the next. Okay, the second type, the types of multimode, because in the multimode also there are several categories. So the one we can say is the step index. Okay, and the second is the graded index. So these are the two types people can classify it under this multi-mode, but in some other place people are also classifying this as types of refractive index based on the type of refractive index. Okay, so no need to worry, either you can classify it under multi-mode, okay, step index, graded index, or in some particular book the same thing they have given under this based on the refractive index. Okay, both are same almost, no need to nothing difference. So you see step index multimode optical fibers and the graded index multimode optical fibers. Okay, again if you go through the naming itself, why we are saying step index, okay, and why we are saying graded index. Okay, so now I will come to that. Let me draw it over here. So as I see, this step index, graded index, all we can define based on the core. Okay, now you see if core, if there is a let's say slightly change in the refractive index value of the core itself, okay, or you can consider that there are multiple layers. Okay, there are two kind of case you can find in which the core diameter or the core diameter is fixed. Okay, refractive index is also uniform throughout the core, and in the second, your core diameter itself is changing in form of slightly it is decreasing towards the cladding side. Okay, so based on that one can classify it step index and graded step index. Why we are saying? Because suppose this is my core, this is the core part, this one, and the top of that you see cladding. मैं थोड़ा सा बड़ा कर देता हूँ scale so that this will be the cladding part and this will be the core, just to understand. Otherwise this is of equal length only, but to see. So here the core diameter up to this part, okay, let's say it is 1.5. Okay, but at the cladding end, I mean this cladding diameter you see which is here, this distance will be the cladding here and here. So let's say if the cladding refractive index, okay, will be let's say 1.3 or something. Okay, now you see there is a decrease in form of step, so that after 1.5 directly this 1.3 is coming. So there is a change in the refractive index of core and cladding in a form of step. We are saying कि sudden change आया 1.5 से 1.3 या 1.5 से 1.4 और 1.5 से 1.2 also. So that thing we are knowing as a step index. यानी आपका refractive index कुछ था core का, cladding का कम हुआ, लेकिन there is a decrement but in form of a step. It is not gradual decrease. Okay, so there is a second case also here in this. So this is the graded index. Graded में क्या होगा? The core diameter itself is changing, okay, based on the refractive index. So basically, suppose diameter is same, but the central part of the core will be maximum refractive index, and slowly towards the cladding side, the refractive index is changing gradually. That's why we are saying graded index. Gradually in the sense, suppose say at the center, let's say 1.5 will be there, then the immediate layer will be 1.49, 1.48, 1.47, 46, 1.45, like that, and there are multiple layers with decreasing refractive index towards cladding, and at the cladding you will come to this point 1.3. So that is how that kind of optical fiber we are saying graded index. Yes, kind of sequential. You can consider that there are multiple layers with different refractive index, and remember at the center the refractive index is maximum. As soon as you move away from the cladding side, the refractive index is gradually decreasing. Okay, and at the core cladding interface, okay, where the core and cladding are matching, so at the core cladding interface, the difference between the outer layer of this core diameter and the cladding diameter, the outer layer of the refractive index of the core and the cladding refractive index is almost near. Okay, very small changes you will see. So that kind of setup we are knowing as a graded optical fiber. So again I am repeating, in step index your refractive index of the core is uniform throughout the core but suddenly changing at the cladding side. Okay, but in graded index your core refractive index is gradually decreasing. At the center it is max, but towards the cladding boundary it is getting decreased. Okay, and there is a very small difference between the outer layer refractive index of the core and the cladding part. So that's why we are saying as a graded index multimode optical fibers. So I hope it is clear to you. Okay, so I have written the same thing. Yes
सर मतलब
Yes.
ऐसा बोल सकते हैं कि स्टेप इंडेक्स है उसमें मतलब टीआईआर जैसा होगा, और ग्रेडेड इंडेक्स है उसमें मतलब जो हम 12th में पढ़ा था मिराज जैसा वैसा।
इसमें
मतलब
सी करेक्ट, फर्स्ट वाला पॉइंट आपने सही पकड़ा, उसमें तो टीआईआर होगा ही होगा। ठीक है, सेकंड में क्या होगा? सेकंड में भी टीआईआर होगा लेकिन मल्टीपल टाइम्स होगा, बिकॉज देयर आर सेवरल लेयर्स ऑफ डिफरेंट refractive index. Okay, and again we know that to follow the TIR the requirement is the light has to travel from dense medium towards rare medium, right? And that is why I told you that at the center the refractive index has to be maximum and slowly decreasing towards the cladding. So each time the layer is changing, different layer of refractive index, your light is getting TIR again. It has to follow the TIR pattern again because it is moving from dense to rare medium. Are you getting that? So
सर ऐसा
multiple
जरूरी
TIR
नहीं है कि सारे जो मतलब जो सारे लेयर्स हैं उसमें सब में टीआईआर ऐसा जरूरी नहीं है, सिर्फ बेंड भी हो सकता है ना, मतलब फिर लास्ट में टीआईआर हो ऐसा भी हो सकता है ना, जैसे मिराज में
वो
होता था।
वो भी है।
नहीं,
अल्टीमेटली
TIR
आपको
होता
क्या
था।
देखना है, आप लाइट आपका मूव कब करेगा, जब वो टीआईआर पैटर्न को फॉलो करेगा तभी। अगर वो टीआईआर को फॉलो नहीं करेगा तो आपका लाइट आपको आउटपुट पे मिल ही नहीं पाएगा। तो आपको वो जो क्रिटिकल एंगल, जो एक्सेप्टेंस एंगल जो फाइबर के अंदर बनेंगे आप, क्योंकि बिकॉज नाउ द लेयर्स आर चेंजिंग, ओके, कोर इटसेल्फ देयर आर मल्टीपल लेयर्स यू से विद डिफरेंट रिफ्लेक्टिव इंडेक्स, सो इट हैज टू फॉलो, अदरवाइज किसी भी मूवमेंट पे अगर वो सेटिस्फाई नहीं हुआ क्राइटेरिया, देन यू विल नॉट क्लेम कि यू विल सी द सिग्नल एट द आउटपुट एंड। ओके, तो आपको इसी टाइप से डिजाइन करना है सब कुछ, कि जब आपका जो सेटअप मूव करे, जो लाइट आपका मूव करे सिग्नल, वो आउटपुट पे आपको मिल जाए। We'll come to that picture, okay, but here it is clear the difference between the step index and the graded index.
Yes, sir.
Then let me move to the diagram. So all such queries will be over with this. Here you see one by one. Okay, so this is your step index. Okay, ये आपका, let's say this is outer jacket. Okay, this yellow color outer jacket here because this is circular, so you see two double you can see, and this is your cladding. Okay, and at the center you see this will be the your core part. Okay, where the refractive index is higher, again I'm saying, compared to the cladding and other part. And you see now this I have compared on the refractive index profile. So you see the input signal. Okay, the input signal, the intensity is very high, so let's compare, let me say it is 100% input signal. Okay, but at the same time you see the output signal, this peak you see, can you see the difference? So which output you will require? This is my input, that this much amount of input I am supplying from the beginning, from here somewhere some light source will be there at this side. Okay, and the input signal will be of this intensity, but you see the output, I am getting this lower intensity.
Is there so much change?
Hello, sir. You are not audible.
This,
Sir, you are not
yeah,
audible.
okay,
सर
okay,
अभी
now is it
अभी
all?
आपकी आवाज कट गई थी थोड़ी.
Okay,
I
fine,
wanted
anyway.
to ask that why is there so much difference between the output and the input signal? Is there so
Yeah,
much of the energy loss?
yes, you are right, I am coming to that only, let me explain one more time.
But sir,
It seems
TIR is supposed to having almost none of the energy loss.
no, let me come to that, let me discuss this part once again. Okay, so you see again, this is your outer jacket part, yellow color. Okay, this will be your cladding part. Okay, so and then this is your core part where the refractive index is high. Okay, now you see this is the multi-mode only, because more than one mode is allowed, more than one path is allowed inside this. And now compared to this refractive index profile, वो भी आपको दिया है कि ये core का, ये see this part, ये प्रोफाइल में दिखा रहा है, so this part, that means it is higher compared to this if you go on this scale. Okay, so refractive index for the core is large compared to the cladding side, that's what this picture is representing over here. But coming to this profile, this one, input and output signal part, so in the input signal you see the intensity is very large, almost 100%. You say that your source, whatever the source is there over here, it is emitting the 100% light, so you get a high intense signal over here as a peak. But at the same time you see on the other hand output signal, provided if this distance is large, of course, then only you will see this kind of very less output, because all such signals are getting dispersed and you are getting a very less output over here. Is it clear? Why? Because there is a dispersion phenomena happening over here. You consider again a case, maybe I last time I told you that suppose you are in the class of 60 to 70. Okay, and you can imagine if all 70 are talking with each other, or they are making noise in the class, then what will happen? The resultant output will be almost negligible. Are you getting my point? Because resultant or the output part will be very less in that case, because each one is trying to say their words or something, or they want to come out with some different answer or something, so it's maybe very difficult. But you remember one case where only one person will be there in the classroom, then you can imagine the output performance almost, because no one is there to make it interfere. Clear? So same thing over a long distance. Again, I'm saying over a long distance, you see this kind of output, but over a limited distance, this output peak may be little bit larger like this also. But of course, remember in mind, for a long distance, this output is getting less and less because this dispersion is going to be happen continuously and your output will be less. It's clear?
But
We'll
sir,
come to that. Yes.
sir, optical fibers are known for minimal energy losses while the transmission. So why this step
Yes.
index fiber is being used if it is providing such a less output in it?
Yes, what I said to you, see, in a world, okay, each and everything which you can look at in your surroundings, okay, that has some meaning. ओके हर एक का किसी का कुछ पर्पस होता है राइट हर एक का कुछ रिक्वायरमेंट होता है यू कैन नॉट एक्सपेक्ट कि मैंने कोई बहुत अच्छी चीज बना दी तो सारे लोग वही यूज करेंगे नो इट डिपेंड्स ऑन सो मेनी फैक्टर्स कई बार कॉस्ट का फैक्टर मैंने आपको एक बताया दूसरा अवेलेबल है कि नहीं आपके यहाँ पे जैसे एग्जांपल मैं आपको दूं मेनी ऑफ द थिंग्स मेनी ऑफ द हाई क्वालिटी फाइबर्स ओके sometimes people are knowing as a wavelength shifting fiber also so that kind of fibers are not prepared in India. We need to import them from Japan or any other countries. So now you look at it is not like that things are not there. Things are there, but it may be very difficult to manufacture. Okay, because of their intrinsic formula or properties. Okay, and they people are not sharing with us, so it's very difficult for us to make it that. Okay, so several things are there, and based on that, we need to limit ourselves sometimes because of the limited technology and limited knowledge, and that is why we are going to use this kind of things. Okay, many a times I said cost factor will be the important for a country like us. So if our work is okay, right, if we are getting our job done somehow, then we are okay with that even though some losses are there. Are you getting my point? But if you have all such resources, if you have all such money with you or something with the other developed countries, so definitely they are going for the higher standard, okay, or the high quality optical fibers, not with this step index. Clear? So step index आप यूज कर सकते हो जहां आपको लगता है कि मेरा पर्पस बहुत लिमिटेड है आई कैन गेट द सिग्नल आई कैन प्रोपोगेट द सिग्नल इन ए लिमिटेड डिस्टेंस आई कैन गो फॉर दैट फाइन एंड दिस इज ऑल्सो जस्ट फॉर कंपेरिजन पर्पस जो पहले बनाया था लोगों ने राइट सी हम लोग सारा कवर करते हैं हिस्ट्री से लेके आखिरी तक तो ये किसी ने बनाया होगा सपोज सिंगल मोड के बाद किसी ने सोचा कि चलो मल्टी मोड ट्राई करते हैं दे ट्राइड एंड द फर्स्ट दिस वाज द फर्स्ट केस ऑफ द मल्टी मोड स्टेप इंडेक्स सो दे ट्राइड इट राइट एंड दे कम आउट विद दिस प्रॉब्लम कि नहीं यार इसमें ये प्रॉब्लम होता है मेरा सिग्नल बहुत ज्यादा लॉस हो जाता है so then again in the secondary step they thought of removing this outcomes right कि इतना कम अगर मेरा आउटकम आ रहा है so इसको ये प्रॉब्लम को मैं कैसे सॉल्व करूं कैसे ओवरकम करूं and that is why they come up with the idea of graded index optical fiber. See, it is a slowly development stage you can consider also. Previously single mode, then they thought of multi-mode. Multi-mode also they started with the step index, then they faced this problem. Then they come up, see, important point, again, I want to convey to you people is, in a particular system, whenever you design, okay, since you are from the engineering background, if you design something, there are several problems, right? Important is, it is not the problem, important is the identification of that problem. ओके आपको पता लगे कि एग्जैक्टली प्रॉब्लम आ कहाँ रहा है मेरे सिस्टम में दैट इज वेरी वेरी इंपॉर्टेंट बिकॉज इफ यू डोंट नो वेयर एग्जैक्टली द प्रॉब्लम इज देन यू आर नॉट एबल टू प्रोवाइड द सॉल्यूशन फॉर दैट so same way they have picked the problem that okay this was the case this dispersion is happening inside the optical fiber okay and because of that we are getting less output now so we need to work on such a mechanism in which we can minimize the dispersion of course you cannot completely remove it okay because multi modes are there so it may be very difficult but you can minimize the losses you can minimize this dispersion losses so that you will get the higher output at the other end. Okay, so it's a development stage. Earlier they come up with this one, this is not working properly, then they are moving for the graded index optical fiber. Now are you getting? Your point is absolutely right why we are using this, but फर्स्ट सी इट्स अ डेवलपमेंट सो पहले मैंने ये बनाया नहीं अच्छा लगा फिर अब मैं दूसरा और कुछ काम किया वो ग्रेडेड आया ग्रेडेड से भी अगर मुझे लगता है कि मेरा आउटपुट फुलफिल नहीं हो रहा है देन अगेन वी नीड टू थिंक ऑफ सम अदर टेक्नोलॉजी बाय विच वी कैन मिनिमाइज अगेन दैट लॉसेस सो आपको आउटपुट जो है वो परफेक्ट मिलेगा. Okay, so let me come to the graded index so then it may be clear to you people. Fine, again few important points. Okay, regarding this step index will be there, so let me go through that so this part will be clear, the step index completely. So you see, so this step index multimode fiber has a large core. Of course, you have seen in the diagram also, and up to let's say 100 microns. In case of single mode optical fiber, if you remember, the core diameter is around few micrometer, 5 to 10, 15 micrometer only. But here you see in the step index, the core size is up to 100 microns also. Okay, diameter pipe. So that's why we are saying it's a multi-mode optical fiber also, because the core diameter is large compared to the single mode. Second, you see, so what happens if you go for the step index? So some of the light rays may travel on direct route. Okay, some may travel zigzag. Okay, diagram से फिर से देखेंगे. Some of the light rays may travel a direct route. Others may follow the zigzag one. Okay, and bounce of the cladding. We'll see the diagram. We'll discuss this. And you see again third one. The pulse begins to spread out. क्योंकि जैसे जैसे see if arrival time is different, okay, propagating time is different, then the pulse is going to be spread and thus losing its well defined shape which is there at the beginning, and hence this type of fiber is best suited for the transmission over a limited distance or the short distance. Okay, let me come to the picture again so that you can see. Here it is. Can you see it? This part, this green color. So this is also one possible path, direct straight. Others are following some different path, making certain different angle, but of course they need to follow TIR. All such waves paths you see, they need to follow the TIR, then only they can propagate and out from this optical fiber end. Okay, important is what I was discussing, you see now in this picture. Okay, this will give you the more clarity in that. This picture is very enough. So this is the problem we are facing in step index. Okay, we are knowing as a modal dispersion. Now look at again same thing, that fiber step index only. This is your outer jacket, yellow color, and this color basically representing cladding, and this part will be the core. Okay, now see, as I said, if you look at the beginning, the intensity is very large. It is from the source, and remember, source is emitting multiple wavelength. Okay, multiple signals, you say multiple frequencies are going to be out from a particular source. Okay, so मैंने यहाँ पे क्या किया, I just represented with different color. Don't consider as a wavelength, I am just considering as a signal emitting out from the light source. So in the beginning you see, if all such signals are at the same place because it is emitting from the source, okay, so collective intensity will be very high. Okay, again I am telling, don't consider this as a wavelength of red color signal or this. You simply consider as a signal, okay, light signal of a particular source, from a particular source. So here the intensity will be maximum. Okay, now when you incident this light on this optical fiber setup, what happens? Depending on their angle by which they are entering, they are following the path inside the optical fiber. You can check it out. All suppose this red one is striking over here, blue one is striking over here, green will be like here, so something, and one is directly going like this also. Okay, now important thing is this one. So depending on their striking time, you see red one is earlier, then you see this blue, and then this green. They need to follow this path like this. Okay, so what happens, according to that, they have to follow TIR and they need to come out from this end, from this side. And here you see the outputs will be like this. Okay, so you see this first signal, this second signal, this third signal. So what happens, the difference from beginning to this end part is, here all the signals are at the same time, so collective intensity will be higher. Intensity strength is almost same, signal strength is almost same. You see, this is also of the same height, this is also of the same height, this is also of the same height, and same height you are getting over here also. But the important point is, at the beginning they are at the same place, so collective intensity will be higher, but at the output all are coming at different time interval. Can you check it out over here? So that is why, rather than a cumulative peak like this, they are spread, the pulse is spreading like this. So this, let me annotate one more time. So this part is getting spread something like this. Actually it has to be like this only, but
सर
it is
अगर
getting spread.
सर
Yes,
सबको सेम एंगल से इंसिडेंट करवाएंगे तो फिर आउटपुट ज्यादा मिलेगा ना?
हाँ मिलेगा, लेकिन मैंने आपको क्या बोला, ये डिपेंड करता है पाथ्स के ऊपर. मल्टीमोड के अंदर कई सारे पाथ है, सो यू कैन नॉट एक्सपेक्ट कि सभी एक ही टाइम पे पहुंच जाएंगे, क्योंकि सबका पाथ अलग अलग होता है आने का, राइट. अगर जैसे मैं आप ले लो कि मैं आपको बोलता हूँ आपको यूनिवर्सिटी में आना है, आपके घर पे जाना है, तो जिस जगह पे आप हो वहां से कई सारे पाथ पॉसिबल हो सकते हैं, किसी में आपको 5 मिनट लगते हो, किसी में आपको 10 मिनट का टाइम भी लग जाए, किसी में आपको 6 मिनट भी लगते हो। सो दीज आर द पाथ, यू कैन नॉट एक्सपेक्ट कि सारे जो पाथ का जो टाइम इंटरवल है वो सेम लगेगा आपको, आप किसी भी रूट से जाओ आपको सेम लगने वाला है, नो, देयर मे बी सम डिफरेंसेस स्लाइटली। सो दैट इज व्हाई यू कंसीडर दीज आर द पाथ्स, ओके, आपको एक एंड से दूसरे एंड तक आना है, बट देयर टाइम इंटरवल इज डिफरेंट, अराइवल टाइम इज डिफरेंट, ओके। सो सबकी इंटेंसिटी तो सेम थी, यू सी, बट आउटपुट में भी सेम ही मिल रहा है, सबकी इंटेंसिटी सेम ही है ऑलमोस्ट, सिग्नल में लॉस नहीं हुआ, लेकिन जो अंदर का मैकेनिज्म है उसके कारण से जो आपका इनपुट जो है वो हाई था पहले, बट आउटपुट जो है वो आपका स्प्रेड हो गया। आर यू गेटिंग दैट? नाउ कैन यू अंडरस्टैंड द पॉइंट?
Yes, yes.
राइट, ये सिग्नल उतना ही था पहले जितना दिख रहा है आपको इंडिविजुअल, यहाँ आउटपुट में भी ऑलमोस्ट सिमिलर ही है, ज्यादा लॉसेस नहीं, बिकॉज ऑप्टिकल फाइबर्स आर हैविंग वेरी लेस लॉस, but this mechanism by which this signal is propagating, this is something which makes the difference, okay। so इसके कारण से आपका क्या हो रहा है, जो पल्स में स्प्रेड हो रहा है, so this we are knowing as a pulse spreading, and of course you can see here it is high intense peak, here it is a broad peak or broad pulse because of this setup only, nothing else, okay। so this phenomena we are knowing as a dispersion, okay। and of course now again you see it is possible only in the multimode step, मल्टीमोड ऑप्टिकल फाइबर, वेदर इट्स ए स्टेप और ग्रेडेड, दोनों में होता है, बट मल्टी मोड में ही होता है, सिंगल मोड में होने की चांस नहीं है, बिकॉज देयर विल बी ओनली वन मोड, सपोज ओनली वन सिग्नल विल बी देयर लाइक दिस, सो दिस ओनली विल कम आउट फ्रॉम द अदर एंड, सो ऑलमोस्ट सेम इंटेंसिटी सिग्नल यू विल गेट इट, लॉसेस मिनिमम होंगे, एंड दैट इज व्हाई वी आर प्रेफरिंग फॉर लॉन्गर डिस्टेंस, यू ऑलवेज नीड टू गो फॉर द सिंगल मोड, बिकॉज उसमें डिस्टर्बेंस होने के चांस काफी कम है।